Okay, welcome back. We're going to be doing some rehauling here of this next update because my current tactic is not working. We take a look in our play state here. We need to scale this because there can be more than one stone in each space. So if we take a look at it right now, we can place them in empty spaces. Sure, but if we toggle to a move, this will only allow us to highlight whatever our color control stack is. And then when we click on it, it needs to take it out, right? And then only allow us to move orthogonally as long as there's no standing stone in the way. But right now we have it where it's just, it's busted. It just takes it out. So we need to rehaul. We need to do things differently because we need to allow the stones to be stacked. So if there's already a stone on there, we need to be able to say, hey, if there's two members on one occupant, that's the classes that we've made to allow us to stack them on top of one another. So how do we go about that? So our occupant is what we're calling the grid space, and our member is one stone, basically. It's got a stone color, a stone type. And I need to move this control stack into the occupant. So I guess a good thing to try here is to modify our code so that I would probably undo what I've done in the move type move clicking detection. Probably take that off for now, and I just want to be able to give an occupant multiple stones so that I can say, I want to be able to say, hey, if there's 3 stones, white, black, white, in one occupant, first of all, how do we render that? Because they're stacked on top of one another. But second of all, how do we track the stack control? And then the trickier thing is probably going to be it's definitely going to be how to implement the moving of a stack and to have the adaptive rendering depending on how many stones are actually there. So that's what I'm going to try to tackle, but I don't think I'm going to get very far. I'm hoping, and I always say this all the time, but I'm hoping to get programming done in the morning so it's not late, because I start to get sleepy and then I yawn and then I don't want to program. So I guess for now, I'm going to take this off. I don't really care about the move type of move click detection at the moment. But I do want to be able to say, I want to be able to give ourselves multiple stones. So multiple stones in the same occupant. Multiple members, rather, in the same occupant. So, how do we do this? So if we take a look here, we go through every grid, we give it an occupant member, and then we take each grid's X and Y and we assign it to be the correct values, and then we give each occupant a member field, and each member field index has a member object that we're instantiating at an X and a Y of the same grid, but the first two arguments are registered nil for the moment. So I guess I want to test something like, let's say, this is in our init function. So what if we say, and the thing is the grid, the 2D array of our grid table here should go grid I, 1, 2, 3, 4, 5, then grid 2, no. Grid 1, yeah, let me think this through. So our grid is just a two-dimensional array, 1 through 5. And if we take a look, we render, oh God. Yeah, so if we take a look right here at these grids, 1, 1 is here, 5, 5 is here, so it goes 1, 1, 2, 1, 3, 1, 4, 1, 5. So the first one is the first row, 2 is second row, so the second bracket is our column, first bracket is our row. So let me just write that down for me to remember that. I want to say something like first bracket is row, 1, 1, 2, 1, 3, yeah. Second bracket is our column. Now, I want to be able to say something here like if we take a look at what happens when we click in a spot that's empty, the code is, oh come on, here it is. All we do is populate our members field with a stone color and a stone type, and that takes in a string. So we also need to flip its .occupied field to become true, and that is so that we render it, I'm assuming. Because if we look at our member, no? Where do we use that .occupied? I guess we just do it right here. We use it here so that we can't place it in an already occupied grid. So I'm thinking if we just right here, if we can manually populate our grid, I'm hoping. So this is the first grid, the top left. I'm going to say that its members at index 1. Remember, we have 10 of those members. So I'm going to say the members 1 in its stone color field gets assigned black. And then I'm also going to say the stone type Let's say it gets a capstone, just for fun. Stone type gets a capstone. Now I just want to see if this populates, which I'm hoping it does. Yeah, we don't do the occupied, so it still renders the control grid highlight, which is fine. I'm going to switch this to a laystone, and then I'm actually going to just give us... And actually, it's the occupant in the occupied field. Yeah. So grid 1-1 is a table that's holding an occupant, and that occupant's dot occupied, yep, is going to be swapped to true, and then that should stop it from rendering that highlight around that space. Yes. Cool. So we've got the occupant, and if we look at our debugging, it says we've got a stone color black there, a laystone there. Control is nil, so we actually need to set. Occupant needs control, so we're gonna initialize it to nil, and then our stack control will just get a string. So we're gonna say grid at our 1.1 in our stack control field gets black, and we're just manually coding this right now because I want to get them on the screen so that I can test adding more members and seeing how they're going to render. So now we're rendering a dot control, so we need to give us the correct, not dot control, but our control stack, or stack control rather, stack control. Convert that to a string, and now it should be populated black. Yes, stack control. Yeah, I want to say that this is actually stack control right here. Okay, so I'm gonna be it cuts it off, so maybe I'll just put dot control there. The next thing I want to do, we need to do something. We need to be able to add another member, right? Now we need to be able to set we need to, since it's a top-down game, the first square completely takes up the square, right? So what is it? I've got a shortcut button to hit to hide the stone. I'm just not seeing what it is. I don't remember where I put it. Did I take that off? Keyboard's pressed. E. That's what it is. Toggle mouse stone. E. Okay. So yeah, the stone right here, if we render another stone on top of it, it can't just cover, like let's say we render a white laystone on top of it, it can't just overwrite it because we need to see that it's stacked. So we need to do something like the members, if the members, the higher, if you imagine looking at the board sideways, member 1 is on the bottom, it's the first right above the floor. Members 2 is going to be the next one, members 3, members 4, members 5. So as those members indexes increases, their rendering needs to get smaller so that we can theoretically see them rendered on top of one another. So we need to do something to our member render here. Instead of rendering it instead of rendering it a given we've got an X, a Y, hold on a sec. Yeah, so the 120 right here. So like, let's say 120 by 120. I would have thought that they were 144. Oh no, but it's the, let's make sure, if we open up our constants, I'm pretty sure our 120 comes from the 144 minus the outline width on all the sides. So if we open up, where's our constants? Outline width is 12. 144 minus 12 is 136, minus another 12 is 1. Shoot. Yeah, so the 120, yeah. Yep. Okay, so the 120 is, yeah, our 144 grid minus the 12 outline on the right and left and the top and bottom. So if we take our, we want to give this to be a constant, like a lay stone width constant, or a stone width. We do a stone width constant here. That means we're setting our default stone width to be a 120 constant. But then if we take a look at our members, we also need like a we moved the control field into the occupant class, so we no longer need that. But our member needs a member order. Which we can use this order to determine how thick we want to render our laystone, for example. So if we put our stone width constant here, actually maybe stone length is a better word because it goes for the height as well. Stone width, stone length. Yeah, stone length is probably better because length can be whatever. So we're going to say stone length gets that 120. We're going to say our stone length is the number of which we render our rectangle. But then here's where the magic will happen. We're going to say, we need to, it's like upon assigning it, we need to determine the order. So if it's an empty spot and we just placed it, then the order gets 1, meaning it's the first on the stack. I feel like stack order is more verbose here. Stack order. So if 1 needs to be equal to stone length, but 2 needs to be equal to stone length minus a certain shrinking factor, which if we have spaces for 10 stones and we're 120 wide, we can't shrink it more than 12 pixels. Otherwise, stone 10 will be unseeable. So let's say stone shrink, well, we need like a, just gonna say shrink gets 10 as a constant, right? And then how would we do this? We need 1 to be equal to the stone length, so let me write this down. Because we need 120 is our stone length. 1 needs to be equal to 120. 2 needs to be equal to 10. 3 needs to be equal to 100. So we just need to say it's we take our stone length and then we subtract a shrink from it. 3 needs to shrink by 2. 1 needs to shrink by none. So how do we multiply our stack order? Self.stack order. We need to, 1 needs to get not shrinked at all. So we need to say stack order minus 1. No. Shit, how do we do this? Yeah, it's like we need so on 1, we do the member order minus 1, member order minus 1, member order minus 1, then multiply that by shrink. That's what it is, 0 times shrink. Okay. So we need to do the length plus the member order minus 1 times shrink. So we take the stone length and we add whatever our member order is, or actually our stack order. We take our stack order and we subtract 1 from it. And what this does is gives us a number. If our stack order is 1, 1 minus 1 will become 0, and then 0 times the shrink constant will give us 0, meaning our stone length. Basically meaning we're going to render our current lay stone in 1-1 exactly where it currently is, ideally. And then when stack order becomes 2, 2 minus 1 is 1. 1 times shrink will be shrink 1, it'll be 10. So we're going to be adding, actually we should be subtracting this because we're trying to shrink it, shrinking it by 10. So we need to do this for the width as well. And then now we want to do this order of operations different, I think. I think we want parentheses there to do the subtraction first, because we don't want to multiply it by shrink first with our PEMDAS rules. So we'll add parentheses there to explicitly remove the stack order logic first, then multiply by shrink. So now, hopefully, if we did this right, we should have exactly what we had before we did any of that, which is just a lay stone. Oh yeah, we need to assign our stack order to be 1 upon our lay stone placement. So right here, we'll say our occupant at grid 1-1 in the stack control field gets 1. Now, is that right? No, it's a member. So we need to say that our members table at index 1, that field called stack control gets assigned to 1. Now we should render black laystone right there. Fuck. Stack order. Yeah, not stack control, stack order. Okay, now we should be a black laystone. Number 32. I don't know why that's not working. A number value. So number 32 is fucking up because it's a number. Why would it fuck up? It's supposed to be a number. Attempt to call global stone length a number value. Why does that not work? We've got our globals. Stone length. Underscore. Stone underscore length, just like we have here. Okay. I don't get why it doesn't like that that's a number. It's supposed to be a number because the argument is supposed to be, oh, right here we don't have a minus. Okay, so it looks like we've done nothing because we're still rendering the same rectangle there, but what this allows us to do, we're now rendering based on our stack order, rendering our width and height based on our stack order. So if our stack order is 2, I'm hoping there's going to be a 10 pixel border around the next stone. Look at that. So we did, this makes perfect sense. We just need to offset this. So, shoot. You know what? This actually might not be a bad thing. I was thinking to shrink it so it had space on all sides. But now I'm kind of thinking, well, yeah. I'm just imagining like 5 rows of 10 stones each. If they were programmed like this, they all the top stones would all be in the top left corner right here, you know. The very top stone would be here, where we would probably want it centered so it looks like they're just stacked in the center. So we need to offset our X and Y position based on stack order as well. So I guess that means we would say something along the lines of, already look at our X for rendering, right? It's our X position plus our X offset plus our outline. So we also need to plus it. We need to plus it by our what? We need to move it. We need to move it a stack. No, yeah, a shrink inwards. So we would take our self dot stack order, and we would multiply it by our shrink constant, and that's what we're trying to offset our x by. So we offset our x by the amount we're shrinking, and we shrink depending on what our stack order is right here. So we would say but the thing is, yeah, we don't want to offset it if yeah, we need a -1 here, so we don't offset it if the stack order is 1, but we do offset it if it's bigger than that. So I'm pretty sure our y is the same code for this, where we god damn, look at that crazy line of code. Let's see if that looks like the stone is in the middle now. This is a stack order 2. We didn't. Okay, complete opposite. So half that. So we need to take all of that, do that first, and then divide it by 2. Parentheses, do that first. Yep. Then do that. Then do that. Okay. So yeah, we need to take this. We need to say the same thing where we say do this first, then divide it by 2. We divide it by 2 because of the I guess we divide it by 2 because the offset for the shrink, it wants to be in the middle, not on the right. So we want to divide the shrink amount, or the x amount rather, x and y amount. What did I mess up? We missed a parentheses here. Okay. Right in the center, come on. Booyah. Cool. That's exactly what I wanted. So now, what's tricky is this is only, well, let's see if this scales, right? So like, what if our stack order is actually 3? Does it shrink by another amount and scale appropriately the XY? Yeah, it does. See how it's smaller? So what is our 10? What is our 10 stack order? It should be a tiny square. Yeah, perfect. I wouldn't want to go any more than that. I think 10 is the max stack limit. I feel like, because any smaller than that is just a little wild. So the thing is, we're only rendering player 2 lay stones correctly right now based on that. So what would be nice is if we go here and we modify, let's say a standing stone, its width. That's the thing, let me think. A standing stone has to be on top. So I don't think we should shrink the height. We should only shrink the width. for the standing stone. So instead of the 120, remember our 120 here was our stone width. We're going to say that our stone width gets modified by our stack order offset by our shrink. But we only do that for the width, not for the height. We lock in the height at that 44. So if we do our shrink logic there, based on our stack order, then we can go to our place state here and say, hey, just kidding, this is now a standing stone. And I want to see, first of all, what the first one looks like, and it should be all the way across the grid. Good. Then if we say halfway down the middle, yeah, you know what? I guess, no. Let's see. Yeah. This is not really what I want. Because I want it to be apparent that the standing stone would have to be on top so nothing can go over it, but I guess it's pretty, like the higher it goes, the less likely or the less recognizable it would be as a standing stone. So if we go to like the 9th stack order, it'll look more like a square than a long standing stone, which is not what we want. So I would say we probably want to actually scale the width as well, or the height as well, just not as much. So like we can say we're gonna, the width, Jesus Christ, yeah, this is the, okay, yeah, instead of 44 here, I'm gonna say that actually a standing stone height gets equal to 44 constant, right? And then we're gonna say that our standing stone constant, was it height? I just typed it and I forgot. Yeah. Standing stone height gets modified in the negative direction of our stone width times our stack order shrinked. Fuck. Parentheses, there's the 2. But we want to, this is wrong. We want to say our width, or no, our height gets whatever our default height is, and then shrunk by whatever our shrink is, but we want to not shrink this by 10 pixels every height. That's too small. It'll be gone before that. So we probably need to cut this number in half. So if you do this first, then we divide it by 2. If we're stack order 1, 1 minus 1 is 0. 0 times shrink is 0. 0 divided by 2 is 0. So it'll just be our SS height, which is our 44. So stack order 1 should be the correct height. We're missing parentheses somewhere. We've got 2 here, 2 here. Oh yeah, it's way off. We need another one here. Right. We're doing doing this first. We're doing this second. I think we can get away with this. Okay. Let's see. That's 35. Oh, we need a last parentheses to close the arguments. Normal, one normal, nice. What we also need to do is offset our X position. I think our Y is probably... No, we do. Well, let's see what our Y position is. It's just the offset. I think this is fine. We need to offset here, just like this. Where we need to offset our X by some amount related to our shrink, but it needs to be a smaller amount than our lay stones. So here I'm hoping this still renders normal, and then by the time we shrink it, let's see what our stack order 2 looks like. So it should be a little bit smaller, and it should be scooted inwards a little bit shorter too. Yeah, it's not quite even, but that's about what we want. But let's see what our 5th stack order laystone would look like. Nice. Yeah, I mean it's not centered. We do need to center it with the Y as well. We need to fix our X. So I think we can, this is actually 2, and then we need to do the same thing here, where we offset it in the positive direction, offset our Y in the positive direction based on our stack order. It's not quite in the center. Where's this 50 coming from? Where's that 50 coming from? We did 60 because the height is 120, so half the height would be... What the heck? I don't get it. It's too low. So in our Y, yeah, our plus 50. Why is it a plus 50 there? Okay, so the plus 50 was the offset for the height. Oh, shoot. Yeah, this is different. Because the height, well... let's see. See, that looks too high still. That looks about in the middle, yeah. Maybe it looks a bit low. Well, let's see. That will be even lower. Okay. Well, let's change the stack order real quick. Let's see what our 8 would look like. See how off that is? Should be centered. So our 8's wonky. Our 2 also wonky. So it's just our Y that we're fucking up. But so look, our X, Jesus, and our Y. So we're taking our stack order, subtracting by 1 to get a scale for the shrink, dividing it by 2 so it shrinks not so much as the lay stones. You know what? The shrink shouldn't be on the Y. Wait. No, yeah. This is confusing. It's hard to figure out how to scale this while keeping it centered, because the center is dependent on how tall it is, and how tall it is dependent on the stack order. The stack order modifies its width, but we're using the same width here, so why is it that we offset the laystone by the outline so that we can place it not on the grid but right inside the outline border? So it's like we need to modify this. We need to say yes, do add the outline, but we don't want to draw a skinny thing right at the top of the inside of the outline. We want to also offset it by what is the question? I think we want the Y to always be the same number. We want it to be the stone width divided by 2, which would be we do stone width divided by 2. That gives us right in the middle. Yeah, then there will be see what this looks like. Yeah, 2 shifted too low. Ay, 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 ay. Why is it so hard to think? The y would always be... No. Yeah, dependent on... Okay. This is so jacked. Look at the code I have for where the y goes right now. Oh, come on. X. That is not right at all. Look at that stupid crap. That's the y we have. Current y plus the offset plus the outline, shifted by the stone width, shifted by the height, minus the stack order times the shrink divided by 2. I think this gets us closer to it. It gets us to be like the middle. No, not at all. Fuck. What the heck, man? Shit. If the shrink order for this is 5, because it's the shrink divided by 2, for the height, then what we want to do with our y is to say, hey, it's our y. Let's just restart this. Because we need to draw it in the middle of the grid. The grid's 144, but there's an outline that's 12. And then in order to get the exact middle, we need to know which stack order it is, because that changes the shrink offset. So first of all, let's just get it to be drawn. Let's get the top left of it to be drawn exactly in the middle. So our self y gets us our grid. Now our grid's 144 out of 144, so half of that would be 50, 60, 72. So if we shift our y by 72 lower, it should be exactly in the middle, which should look like it's favoring the bottom because of the width. That should not be right at all. Why does that look exactly like I just did it? Well, okay. Why does it look like it's not right? That should be half. Our x is there, our y. Oh, it's because the y offset. So yeah, we do need to add the y offset. But then if we add the 72, the y offset is just the offset for the grid, because we're placing it not in the top left corner. But now that should look like it's in the middle of our screen, or of our grid 1, 1. No, it does not. Y plus y offset. Fuck. So this should be the top left of it. No? Top left. Minus, not with our outline, should be over our outline. Yeah, so it's over our outline. So how come we can't get this in the middle? Because if we offset by half of what our width is, or our grid height is 144, so half of that is 72, right? So that should get us the top of our lace stone is right in the middle, but it doesn't look like it's right in the middle. It looks way lower. Why does it do that? So if we plus our outline, now it should be flush with the top of the outline there, not overlapping it. Yes. And then the y, so now this is 120. So now if we add 60, It should be right in the middle, but that's not what it's doing. That's not really in the middle, is it? Maybe it is. Yeah, it does actually look just like it's in the middle. So the thing is, instead of drawing it there, right in the middle, we need to shift it upwards by half of its height. So we need to get its height, shift it upwards by half of that amount. So if we look at its height is this, which is the height minus the stack order times shrink divided by 2. And that's our current height. So we need to shift it upwards, meaning we minus our height, but we don't need to minus our height. We need to minus half of our height. So now that will hopefully get it to look like it's right in the middle there. Parentheses. Come on, middle. That looks pretty middle. So now the moment of truth comes when we change the stack order. So like, let's see what stack order 5 looks like. Hopefully it's still in the dead center. That looks pretty good. And it is getting thinner. And then by 10, it should be as thin as it gets, as small as it gets. Right in the middle. Holy crap, that's so tiny. Yeah. A laystone shrinkage, or a standing stone shrinkage, is maybe just a bit too much. I was in the pool. Yeah, that's about as small as we would want it to be. So we need to do something to make it less small. And what we're doing to make it less small is a shrink divided by 2. But if we shrink it by a bit less, divided by 3 instead of half, it's a third, or instead of shrinking it by half, shrinking it by a third of that value, shrinking it by less. And then we need to shift its y by the equivalent shrink scale. And then 9 will hopefully be a bit thicker, but still look like a standing stone, hopefully. It doesn't look like a square, which is good. And it's not so thin. We'll see what the 10 looks like, the smallest standing stone. There's 9 stones underneath and a standing stone on top. That's what it looks like. Now, I think it should be a bit smaller. Let me make sure that our stack order 2 would be thicker. Yeah, okay. So I think we just need it to be a bit smaller. So we need maybe instead of a 3, or maybe it's 2.5, I don't know. And then okay, so let's see what 9 looks like. So now we're rendering the shapes based on their stack order, which that's looking better. you know, thinner. That looks like a standing stone. If you imagine 8 stones underneath it, let's see what our 10 looks like. It is looking thinner, more like a standing stone. That's fine, I guess. I mean, I doubt, you know, it's going to be pretty rare you're going to get standing stone on top of a stack of 10, but I think it's one of the limitations of trying to do this 2D game when it's a 3D stacking game. So right now we've got standing stone, or we got laystone, we got standing stone, and we need a capstone scale for the capstone. And then we need to do the other color. Let's see. So look, this was our old code for renderer, right? It's like, oh, 120, 120, because it's a square. Or a flat, or a standing stone, which is a 120 by 120, 1 by 44. And now, instead of those two values being just so simple, now they're these huge expressions, which is kind of crazy, but not for a computer, you know, it's pretty easy for a computer. I'm getting tired. We're close. Let's see if we can finish out the scale for all of these and then call it a day. The circle's going to be a little tricky, because right now the X, this 72 is like a mount to set inwards. This is weird because the X and Y is the position of the center. Oh, actually that makes it easier because the center stays the same. So if 72 is the dead center, then we just need to worry about drawing the last argument, which right here is 50. So we need a capstone with constant with, or to stay consistent, capstone height gets 50. And then we need to render not 50, but our capstone height, and not our capstone height, but our capstone height plus, minus our, whatever our self.stack order is, minus 1. But we need to scale this by our, so we minus a 1, then we multiply it by our shrink, and that's what we subtract. So 1 should still be the normal size. We need another parentheses here, I think. Okay, so let's see what our, if we change this to a capstone and we say, stack order is 1, should be right there in the middle. That's fine. Stack order 2, it should be smaller by the shrink amount, but the center should be the center still, so. Yeah. That's just looking like it's shrinking too fast. Let's keep upping it. Yeah, it's getting small real quick. Because at 5, it's almost unseeable. That's about as small as we wanted, right? It's hard to say because we can't see what the 4th stone underneath it would look like just yet. But that 5 is about as small as we want it, so we would want 10 to be about that small. So that tells me we need to divide our shrink by 2. and then our 10 will look that small, and our 5 will look twice that big. Well, twice that big. I don't know. So there's our 5. That's looking better. Because then, if we're at 9 or 10, should be smaller, but not crazy. In unseeable small, should be just smaller. Yeah, so we can see that's looking too small probably. So maybe we divide it by 3 instead of 2. I don't know. Shrink divided by 3, and then we'll see what a maximally small capstone at stack order 10 would look like potentially. Which, why did that happen? There's as small as it gets. Which, let's see how small the laystone is. Let's see if it's about that thick or it's a bit smaller, huh? Actually, it's about fine. Yeah, so divide by 3 looks about right for that. We would have to really test. Once we get the white logic shrinking appropriately, that looks just about perfect though. According to the laystone size. So let us fill in. We basically need to do the same thing but for our whites. So our X is now for our laystone modified positively by our stack order by our shrink scale. So we say right here, give that. And then our Y on our laystone is now offset by our stack order shrink scale as well. So our Y offset outline plus the shrink scale, and then our width and a height is now a stone width modified by our shrink. And then our Y is now a stone width modified by our shrink. Now we can test if we swap. If we swap our laystone for a white laystone, tight. We'll see 1, but the 1 should be just a square. Perfect. 2, well, let's go, I guess, straight to 5 and see if it's about, half of that shrinkage. Nice. Cool. And then 10 would be the tiniest. So looks like our white laystone is now correct for the shrink scale, and then let's do our standing stone. Jesus. Okay, so our standing stone, modifying our X by our stack order shrink. So right here, modify it by our stack order shrink. I know there's a way to not have to repeat this for the different colors. Yeah, I'll figure that out in a second here, but right now we need to do the Y of our standing stone, which is modified by this. Oh, holy shit. We say 60 plus the height. Stack order. Shrink divided by 2.5 divided by 2. You know, easy stuff. That's ridiculous. See, we need this outline. So the y offset, and then we plus it by the outline. Y offset, then we plus it. Jesus, okay. And then our width is no longer 120, but a stone width shrinked depending on our stack order. And then our height of our standing stone is no longer 44, but it is our default height shrunk by our shrink based on our stack order. So now we should be able to give ourselves a standing stone white. And let's see how 5 looks. Should be shrunk in the middle with some border on the edges. Perfect. Last but not least, this capstone. Holy crap, man. Okay, so the capstone, all we do is we keep the y offset, we just give the radius, instead of 50, we're doing it a shrink depending on our stack order. So now we should have all of our white stones now translated to our shrink render. So yeah, 5, it's probably fine. And then if we just, for shits and giggles, look at our 10, it's a tiny capstone. Just to assure the white capstone is rendering small, and it is. So here's what's cool, is now, let's say we've got a capstone there at 10. But then when do we do render? We need to render based on the stack order. I think it will. Let's say this first one's a white lay stone at stack order 1. Then our member 2 is a black, let's just say standing stone. And the stack order is 2. So I'm hoping it'll render a white with a black on top, and if it is, I'll jump for joy. Please say 40, attempt and index, no value. Members 2 is a nil value for some reason. I don't know why it doesn't like that. I think, well, yeah, how are we rendering? Jesus. We're rendering the occupant? No. Selection highlight? No. Here. Oh. We need to render each member's to object. Come on, man. 40 is a nil value. It doesn't like that we're doing members too. But we give ourselves a members. Oh, wait. Yeah, this is actually wrong. This should be this. Members I think. Fucker. Oh, K. It needs to be. I didn't mean to just say KKK there. This should be K. Which will give us a member, 10 different members, because K, 1 through 10. Yes. Now it shouldn't crash, hopefully. Oh, yeah. That's it. It looks like the render order works, because if we were to swap the members here, it should say the member 1 is the standing stone with a stack order of 1, and then stack order of 2 for the white one. So now it should only render the white on top of the standing stone. Yeah. Cool. That's right. That's working as I hoped. So, as long as that members is K, which instead of 1, I don't know why I hard-coded it in at 1, but we need to also render each member, which is it's easy fixable with a loop, but I guess just for shits and giggles, I want to say, what if this is a laystone? And then what if we have one more, which is a white capstone on top of that? So we'll say this is 3, 3, 3. Stack order is 3. And it's white. And it's capstone. And the color's white. So now we'll see if the capstone looks appropriate when stacked. Oh, we didn't render it. We've got to come down here and render it. So now it should be capstone stacked. Nice. That's great. So yeah, maybe it's shrinking a bit much, but the capstone, I mean. But that's looking good. That's awesome. That's a big thing. 'Cause now we've got to the point where we can, now when we're moving our objects, we can say, hey, if there's already an object there, your stack order is 1 more than the given occupied stack amount. And that will control how big or small we render it. And let's see what a waystone looks like there instead of a capstone on top, or a standing stone rather. Should be flush. Not quite, because we shrank the Y by, a given amount. That's fine though. We can shrink it by less if we're really worried about it. We just want it to be legible. So without that little bit of border there, it'll actually melt away and it'll look like two standing stones of black, which is probably not what we want. So this way is actually probably fine. Cool. So what did we do today? If we take a look at our git diff, we'll see that we made a handful of constant changes. We gave ourselves a shrink, a capstone height, a standing stone height, a stone width. We took control out of our member class. We gave it to our occupant class for, we moved our control color, or we'll get to it. We changed the rendering based on shrink for both white and black colors. That's the stack control that we moved. We moved that to our occupant class instead of our member class. And then we populated our members table. We populated each indices rather than just the one. That's all the rendering for these test objects that we're looking at. We took out our move type move option for now because we're still testing this stuff. And then we render the other members. And then we render the stack order. Not stack order, but control, actually. Stack control for the occupant. So yeah, basically all we did was scale up our member renders to scale it in the sense that we shrink it depending on its stack order. So we get at everything, commit with a message saying modified stone renders based on stack order. Nice. Then we get push it to our origin main. Oh, no. We don't want to, we can't push via HTTPS anymore. We need to git remote set URL origin to be get remote set URL origin, and we set it to our SSH, which is git at github.com /tag.git, and then if we now if we git push it, it should go to our repository. Nice. Okay. So yeah, now we've got it to where now we can actually modify our move click to place a stone in a different member, which before we didn't have that, which was making it really hard to test any of the logic. So we'll probably have to rehaul our control grid highlight logic. I think we'll have to tackle that when we get to it, but I think we'll probably be doing that because we need to only allow moves if it is a orthogonal empty space or a not capstone or not standing stone space, and then we can render the members. And then what's really difficult is taking the members out, deciding how many to pick up and move, and how those get rendered depending on how much you move or decide to pick up or to drop or where to drop them. An example of that is, let's say we have a stack of 10, meaning they're all getting smaller, right? We only pick up the top 3, which are these tiny little stacks. When it's following our mouse, it'll probably stay that small size, I guess. Then we have to hover over a space you can dump in, drop the spaces, but when you drop them, it'll go from a tiny one on your mouse to, depending on what the thing underneath looks like. If it's empty, it'll be a big full square. So yeah, that's gonna be a little tricky. We have to figure out what the most intuitive way to handle the controls for that is too. So if it's move type move, then you click, then you decide how many you want to move, and then you click how many, or click in which space you want to move them in, and then you drop as many as you want, and then your direction gets locked in, and then if there's no available moves, it needs to switch players. Jeez. It's getting way complicated way fast. I love how like just doing the placement was like easy. And then, there's only two things you can do with your move. Place a stone in an empty spot or move a stack of stones in your control. And that latter move is way more difficult than the first. But we're getting there. We got a good thing done today. I will hopefully program tomorrow again. Trying to do it in the mornings so I don't get yawny at night here, so we'll see how that goes. I always say that, but I don't do it, so we'll see.